Hello students, in this class we are going to discuss about one more total internal reflection of application. In last class we are already discussed about mirrors. In this class we are going to discuss about diamond. Generally diamond has more shining. When you incident a light on the diamond, then it appeared as more shine while compared to glass. When light is incident on the glass, the shining is very low. When same light is falling on the diamond, it appeared as more shining compared to glass. That is why this diamond is called as the brilliant diamond. This is also known as brilliant diamond. So, generally diamond has brilliant nature. Brilliant means shining. Why the diamond is brilliant? Due to total internal reflection. Due to total internal reflection, how the total internal reflection is going to happen in diamond? We know that critical angle IC of diamond is 24 degrees. The critical angle of glass is 42 degrees. Which has critical angle value is low, diamond has critical angle value is very low. Then what happened? We will observe that I am taking, this is a interface of diamond. Interface of diamond. This is the interface of glass. In both diamond and glass, both has total internal reflection is going to happen, but in which has more total internal reflection is possible, we will observe that. I am taking, this is the normal line of diamond, this is the normal line of glass. So, what are the conditions of total internal reflection? Light always passes from denser medium to rarer medium. This is the denser medium, this is the rarer medium. Denser medium, rarer medium. Light always flows from denser medium to rarer medium. This is the angle of incidence. It becomes critical angle. Here value is 24 degrees. Here angle of incidence is 24 degrees. Here total angle is 90. Total angle is 90. When the angle of incidence is equal to critical angle, then the light ray is going to total internal reflection passing through same medium. This is the refracted angle. Okay. How much here angle? So this is totally 90. 90 minus 24, 66. 66 angle is reflected angle. Here you have observed that below the 24 degrees, what happened? Light does not equal to the critical angle. Then what happened? The light going to refracted, that is traveling this direction. After the critical angle means greater than the 24 degrees, what happened? The light ray going to total internal reflection with angle of 66 degrees. Suppose I am taking 1 degree taken as a one ray. So here how many times going to total internal reflection? 66 times. Here also I am taking light ray traveling this direction with angle of 42 degree. So here angle of incidence becomes critical angle. Then the light ray is travel refracted into same medium with angle of 90 minus 42. The ray is going to reflected travel into same medium. Here total internal reflection is going to happen. What about a reflected angle? 90 minus 20, 42, 48 degrees. Here I am taking 1 degree as one ray is going to traveling. So how many times here going to total internal reflection is happening? 48 times. In case of glass, how many times total internal reflection is going to happen? 48 times. In case of diamond, 66 times total internal reflection is going to happen. So in case of diamond, more times total internal reflection is going to happen. Due to this reason, diamond is more shine while compared to glass, because glass has total reflection is going to less. In case of diamond, total internal reflection is going to happen more. Due to this, diamond has more shining. The designers will cut the diamond with possibilities of more times of total internal reflection while making diamond. So this is the one of the application of total internal reflection, diamond. In case of diamond, more times total internal reflection going to happen, but in case of glass, less number of times total internal reflection going to happen, so that diamond will shine more compared to glass. So it is known as brilliant diamond. So why in case of diamond is known as brilliant diamond? In case of diamond, more times or multiple times of total internal reflection is going to happen. That's why it is going to be shine more. In case of glass, less number of times total internal reflection is going to happen. Next application of total internal reflection is prism. If suppose I am taking a glass prism, one object is placed one side of the prism. When light is falling on the object, it forms the image other side of the prism. Inverted image will be formed. It is possible due to application of total internal reflection. It is working on the basis of total internal reflection. When the total internal reflection is possible, when incident angle greater than the critical angle, then light ray going to be total internal reflection that will travel into the same medium. In case of prism, inverted images are formed due to total internal reflection. When the light is fall on prism, it forms inverted image without changing position of object due to total internal reflection, due to TIR, total internal reflection. When total internal reflection is possible, the incident angle becomes greater than the critical angle, total internal reflection is going to take place. The critical angle of glass prism is 42 degrees. We are already knows the critical angle of prism. Now we will observe that how the images are formed in prism. For example, I am taking, this is a one kind of prism. Okay, the name of the prism is PQR. Here angle is 90 degrees, here 45, here also 45. Suppose I am placing one side of the prism, means I am taking one object, placing the face of PQ. This is the object AB. When light is incident on the object, what happens? It is travel this direction. When the ray touches to side of PR, then we will draw the normal line in same direction. Here ray of light is passing through the normal, then what about the refracted ray? Is also in same direction. It will reaches to this point. So here incident ray and refracted ray both are in same direction. When it touches to PQ, we will draw the normal line. This is the normal line of PQ. What about here angle? 45 degrees. Here angle of incidence is 45 degrees. The critical angle is 42. So angle of incidence greater than the critical angle, total internal reflection is going to happen due to the total internal reflection. The light ray going to reflected into same medium. So the ray of light is traveling into same medium. When the ray is touches to RQ, then we will draw the normal line. Here the incident ray is passing through same normal line, so the refracted ray is also come out this direction. Okay. Similarly, another ray is also traveling same direction. It touches to P R side of the prism. It is passing into same direction because the incident ray is traveling in normal. After it reaches to side of PQ, we will draw the normal line. So after, what about here? Angle becomes 45 degrees. Again, angle of incidence is greater than the critical angle, then total internal reflection is going to take place. Then the ray of light is going to reflected into same medium. The ray of light is touches to side QR. At this point we will draw the normal line, but here the incident angle is travel into normal line, so it come out into the normal line. So this is the another ray. So where the image will be formed? Here. So this is the A dash, this is the B dash. Image will be formed A dash to B. What about here angle? 90 degrees. So here image will be formed at 90 degrees with inverted. We are not changing the position of the object, but image will be formed inverted image. Next, I am taking another kind of the prism. Suppose this is the another kind of prism. P, Q, R. I am placing object side PR of prism. This is the object. The ray of light passing through the object AB. This is the ray of light. So here the incident ray is traveling into the normal, so it is traveling in straight line, touches to side PQ. What about the here angle? I am going to draw the normal line. This is the normal line. Here angle is 90 degrees. Here 45. Here also 45. What about the incident angle? 45 degrees. So here incident angle is greater than the critical angle. So total internal reflection is going to happen. So the ray of light is going to be reflected into same medium. When the ray it touches to side QR of prism, then again we will draw the normal line. This is the normal line N dash. Here also angle is 45 degrees greater than the critical angle. Again here also total internal reflection is going to happen. So the ray is going to reflected same medium, so it is travel this direction. When it touches to the side P R, it travel into the normal through the normal, so it moves in straight line. Okay, this is the first ray. Next, second ray is also moving in through the normal line. After it touches to side PQ, when it touches to side PQ, we'll draw the normal line and angle of incidence greater than the critical angle, total internal reflection is going to take place. So the reflected ray is traveling into same medium. When it touches to the side QR, we will draw the again normal line and dash. The ray of light is traveling into same medium. It is come out in straight line. So this is the B dash, this is the A dash. So object we are placing A to B, so A to B dash. What about the angle? 180 degrees. Here also image will be formed inverted, but the angle is 180 degrees. Here we are not changing the position of the object, but inverted image is formed with an angle of 180 degrees. Here 90 degrees, here 180 degrees. Next, another kind of the prism is the shape, how the image is formed. This is the P, Q, R, S. When I am placing the object side PS, here I am placing the object AB. When ray of light is passing in through straight line through the normal, when it touches to PS, the ray of light going to be refracted. The refracted ray is traveling towards the normal line. It touches to the SR. When it touches to the SR side, we will draw the one normal. What about the angle? Angle of incidence becomes greater than the critical angle. The ray of light going to be reflected, is passing through this direction. When it touches to the QR, travel into straight line. Okay. Next, another ray is also moving in straight line, touches to the PS. So the ray of light is going to be refracted, moves towards the normal. When it touches to the SR, we will draw the one normal line. Here angle of incidence becomes greater than the critical angle. The ray of light going to be reflected into same medium. It touches to the side QR. It is traveling straight line. Okay, this is the A dash. This is the B dash. Here object is placed A to B. So image will be formed inverted. Here also inverted image will be formed with an angle of 180 degrees. So what we are understanding? When light is fall on prism, the angle of incidence becomes greater than critical angle, the total internal reflection is take place. Due to that reason, images will be formed inverted with angle of 90 degrees or 180 degrees without change position of object. Here, in case of prism, inverted images are formed due to only total internal reflection application. Okay, that's why this is the one of the application of total internal reflection. Next, one more application of total internal reflection is optical fiber. Optical fibers nowadays we are most commonly used optical fibers. In daily life we are called as the cables to send audio or video signals to long distance. We are sending a audio or video signals to the long distance by using of the optical fibers. Optical fibers means we are seen in homes, cable wires are used to Tata Skies, DTH, where compulsory use the cables. Those cables are called as the optical fibers. What they are doing? Just sending audio or video signals from long distance. So the definition of the optical fibers are: it is a device which send signals from one end to another end of long distance is called optical fibers. It is mainly working on TIR. TIR means total internal reflection. In case of optical fiber, the ray of light going to be total internal reflection. Multiple times of total internal reflection. Due to that reason, signals will be travel from more distance. The inner part of optical fiber is called core. The outer part of optical fiber called as cladding. So core has high refractive index, it acts as denser medium and clad in is low refractive index, acts as rarer medium. For example, I am taking as optical fiber. This is the inner part of the optical fiber, what we called core. It is the outer part of the optical fiber clad in. So this is the core, this is the clad in. Here outside of the core, it can be made with the material glass or quartz. The inside of the core, we are placing a copper wire. When the light ray is entering one end of the optical fiber, it is falling on the glass. So here light is traveling this direction. So when it is entering into the optical fiber, it touches to the core. When it touches to the core, the angle of incidence greater than the critical angle, the ray of light going to be reflected into same medium. Okay. It is again touches to the core part of the optical fiber. Again we are going to draw the normal line. Again angle of incidence becomes greater than the critical angle. The reflected ray is passing through the same medium. Okay. So next again it touches to the core. We will draw the normal line. Angle of incidence greater than the critical angle. The refracted ray is traveling into same medium. So again it touches to the core part. The angle of incidence again greater than the critical angle. The reflected ray is traveling into same medium. So angle of incidence becomes greater than the critical angle. The refracted ray is traveling into same medium. Total internal reflection is going to take place. It is traveling in this direction. So like that, the ray of light is passing in optical fiber. How many times total internal reflection is going to happen? 1, 2, 3 times. Here multiple times of total internal reflection going to take place, so that signals without loss of energy travel long distance. Here particles will be without losing of energy travel in long distance. Then only audio or video is visible or audible. In case of optical fiber, the 90% of energy received by signals travel in 1 kilometer of distance. So the particles are 95% of energy received and travel 1 kilometer distance. So the particles are travel long distance. That's why optical fibers are used in communications. Uses. What are the uses of optical fibers? These are used in telecommunication. In telecommunication, optical fibers are used to send the signals to long distance. Next, these are used to send and receive signals from long distance. These optical fibers were used in two kinds of situations: while sending the signals, while receiving the signals. If you want to send the signals, we will place the optical fibers. If you want to receive the signals from long distance, we are using the optical fibers. In case of optical fibers, multiple total internal reflection is going to take place. That's why here 95% energy will be receives the signals to travel 1 kilometer distance. These are the applications of total internal reflection. First one is mirrors, second one is prism, third one is optical fibers. Very, very important for your board exams. We will meet in next session.
Subscribe now and press the bell icon. Never miss an update.